Thank you for taking some time today to view my 2020 virtual NASPSPA presentation. In this presentation today, I'm going to talk about some research we've been conducting in the motor behavior lab at the University of Tennessee, in which we're using Doppler radar to measure motor behavior. So if you've ever conducted research that involves the measure of kinematics, you're probably familiar with using contemporary methods such as 3D or 2D infrared kinematic systems in which you place reflective markers on a person, and then the infrared cameras measure the movements of those reflective markers, and then a computer provides information related to the angles and velocities in which those markers are moving. We wanted to try to explore a non-contact way of measuring the same type of human motor behavior. So what we explored was the idea of using Doppler radar. And you're probably familiar with Doppler radar because you've heard it talked about whenever you're watching a weather forecast. You oftentimes will hear a weather forecaster talking about how Doppler radar has indicated maybe a strong thunderstorm approaching you, or maybe the rotation associated with a tornado in the area. So the way Doppler radar works is that a large radar will send out an acoustic wave into a cloud, and as the clouds move, it sends back a reflection of the acoustic wave. And so a computer then interprets, based upon the wave, how the clouds are moving. So we were curious, could the same type of technology be used to measure human movement? And so we developed a Doppler radar and artificial intelligence, or AI, that could possibly measure these same types of vibrations of acoustic waves as somebody is moving, and then interpret those vibrations and acoustic waves to help us understand these different measures of motor behavior. So in the study, we had people come into the lab and walk at various speeds in front of a radar that we developed. And the radar sent out a step frequency continuous wave into the lab. Then as the person moved, they created these micro Doppler vibrations that then came back to the radar. So then we developed some artificial intelligence that could record those wave vibrations and then interpret what the movement might be as reflected by those vibrations. What our data showed us is, one, the radar was successfully able to record gait. So as a person moved, the radar was able to receive and record those vibrations coming back. The artificial intelligence that we created was also able to interpret those waves or those vibrations to understand what the person was actually doing. So the AI was able to successfully interpret the direction and speed in which the person was walking. So these data are really interesting because it provides us a non-contact way of measuring motor behavior. So keep in mind that these participants were not having any contact with the machine. They were not wearing any sort of reflective markers. They were just simply walking in front of the radar. So these findings not only have implications for future research whenever we're measuring human motor behavior, but there's also a lot of practical applications. So we start to think about how these types of methods could be used by clinicians, maybe in a physical therapy or occupational therapy setting. They certainly have lots of sport-related applications, medical-related applications, and just a variety of applications related to industry. Well, again, thank you so much for taking some time to view my slides today. If you should have any questions or want to discuss any of these ideas, please feel free to send me an email. Here's my email address. It's just jporter@utk.edu. So this is jporter@utk.edu. Thank you.